In this video, I want to talk about how to do well on standardized exams. So in particular, this is going to be for the Alberta diploma exams for Bio 30 and Chem 30. However, the tips and strategies here can also be used to do well on any standardized exams with multiple choice and numerical response. First, let's talk about some general strategies on doing well on tests, not just standardized tests, but just any tests. It's very important to prepare well in advance. About 3 weeks in advance is ideal, maybe even more. And each of the sessions that you study should be small length in time, about 30 to 45 minutes. It's important to find a way to study that works for you. Some people are very auditory, therefore they like to explain the concept to someone or something. It could be a friend, a pet, or a plant. They don't have to know what's going on, you just need to vocalize it for yourself. For other visual learners, it's important for them to draw or write it out. And it's for everyone, it's important to practice on old tests. So for Alberta diploma exams, there are what we call release items that you can Google on the internet, as well as the Quest A Plus app within the Alberta Education website. If you search for Quest A Plus, you'll find tons of released items, old diploma exams I can practice on. If you want to buy something, there's something called the Key Workbook out there, published by Castle Rock Research. As well, they have an agreement with the Calgary Public Library to create a website called Solero, which is again a compilation of the old diploma exam questions. And lastly, before any test, it's important to sleep, exercise, and eat well the days, at least 3 days, maybe even up to a week, before the test. So now let's look at a specific example from the April 2014 version of the diploma exam in Alberta. So this question, which was question number 9, it says, a drug known as estintide is used in the treatment of type 2 diabetes. Estintide stimulates the secretion of insulin and reduces the activity of glucagon. So there's our context. It just gives you a brief introduction to the material. And feel free to highlight or circle important information. So for me, I believe that the important information is that estintide stimulates the secretion of insulin and reduces the activity of glucagon. So now that we've highlighted the important information, let's think about that, what it says, what it should do in the body. If it stimulates insulin and reduces activity of glucagon, therefore it should reduce blood glucose levels. Okay? And we can think about all of this before even reading the question. So now that we have the basic idea of what this drug does, let's now look at the question. The question says, estintide causes blood glucose levels to, and we have several choices here. We have 2 increase options and 2 decrease options. Well, we just figured out that this drug will decrease blood glucose levels. Therefore, we can then eliminate options A and B. And even though we haven't really looked at the second part of the question yet, we've now narrowed down our choices to 2 possible choices. Okay? And lastly, let's look at the option C and D now. We said it decreases blood glucose level, but how does it do that? Does it increase the permeability of cells to glucose, or would it decrease? Well, if blood glucose levels are being lowered, it's because the cells, let's say your muscle cells or your liver cells, are increasing absorption. And the only way it does that is by increase in the permeability of the cells to glucose. Therefore, the correct answer to this question is C. So in this question, we were able to look at the context information, and just based on that, acknowledge that it lowered blood glucose levels, and then eliminate 2 options. And then we were able to finalize our answer by looking at the rest of the options. Let's look at question 12 from the same exam. We have a diagram here of the endocrine system, and one organ is labeled 1 and the other organ is labeled 2. Before we go any further, we should attempt to label these organs. From our work in the endocrine system, we know that this organ is the thyroid. And this organ here, number 2, which sits atop the kidneys, is the adrenal glands. Okay, so now that we've identified these organs, let's read the question. In the diagram above, the gland that releases a hormone in response to short-term stress is numbered. Okay, so then the key information here is that it's a hormone in response to short-term stress. Therefore, we should remember, oh yes, this is adrenaline. This hormone is adrenaline. Okay, so now we have to remember, okay, is adrenaline released from the thyroid or the adrenal glands? Well, we know it's from the adrenal glands, and hence the name adrenaline. Therefore, that eliminates options A and C. And now we look at the other two options. Number 2, is the hormone released after being stimulated by the nervous system or by the endocrine system? Well, if we remember our work from our endocrine unit, then we know that the adrenal glands is stimulated by the nervous system and not the endocrine system. The endocrine system stimulates the adrenal medulla, which is in response to long-term stress and not short-term stress. Let's move on to a context question. A context question is a question which gives you a large amount of information first before the question. For this type of question, I normally encourage students to read the question first before reading the context. So let's read the question first. It says, which of the following rows identifies the structures that were damaged by the cancer treatment and the process that normally occurs in the structures? So let's look at the structures. So we have interstitial cells and seminiferous tubules. So now we know we're talking about the testes. And then the process either is gamete formation or gamete maturation. Next, let's look at how the options are paired together. We see that we have the interstitial cells being paired with either gamete formation or gamete maturation. Well, we know that interstitial cells is not responsible for gamete formation. In fact, they are responsible for formation of testosterone. Therefore, we know options A and B are not correct. So then let's look at C and D. So now we are looking at seminiferous tubules and either gamete formation or gamete maturation. Well, we know seminiferous tubules are responsible for formation of sperm. Therefore, the option C is correct. Whereas gamete maturation happens in the epididymis. Therefore, this is not a correct answer. So in this case, we were able to answer a question correctly without looking at our context box, at all this reading right here. Therefore, we are able to save time and be more efficient with our exam writing process. Next, on question 28, we have a standalone question. And for standalone question, I encourage students to look at the question, what's called a stem of the question, or just this line right here, before looking, and then try to answer the question before looking at any of the options. So let's try that. In organisms that reproduce sexually, the primary purpose of meiosis is well, let's think. What is the main purpose, the primary purpose of meiosis? If you remember your genetics material correctly, it is to reduce the chromosome number. We want to half the chromosome number so that the cells are going from diploid into haploid for the formation of gametes. Okay, so we want to find an option that is similar to halving the chromosome number. Okay, so A is the replication of genetic material. No, that's not the primary purpose because that would be the purpose of mitosis. Independent assortment of genes, well, it is important, but it's not the primary purpose. C, reduction of chromosome number, which matches to our original answer of halving the chromosome number. So therefore, we know C is the correct answer. However, let's look at D as well. Production of identical daughter cells. Well, that is obviously wrong because that is not meiosis. That is the purpose of mitosis. In question 29, we have a rather complicated diagram, and as well as a context box here, and several options. So in this type of questions, I encourage students to actually go look at the questions first in order to find out what we're trying to answer. So the question says, a karyotype of structure 1 in the diagram would have, okay, so now we're looking for structure 1. Let's go look at structure 1. We found structure 1. And by the diagram here, it looks like eggs. And let's go back into our question then. So structure 1, eggs, these being gametes, they should be haploid. Okay, so let's look at answer options that are haploid. So in A, it says 2 copies of each autosome, which is not haploid, that's actually diploid. So then we can eliminate A. We can also eliminate D by the same process. Okay, so now we're down to B and C. 1 copy of each autosome, and either a W or a Z chromosome. Well, this W and Z chromosome is something new that we haven't looked at. So let's go back into the context box now. Now we can go back to the context box and say, and read. The sex chromosome in adult female butterflies are W and Z, whereas the sex chromosome in adult males are Zs. Okay, so now we know eggs are the female gametes, therefore they should have either W or Z chromosome. Therefore, we know that option B is the correct answer. The key difference between option B and C is the word or and an. In the process of meiosis, there's only 1 sex chromosome. So it's either or, a W or a Z. It cannot be both W and a Z chromosome. And one last note, I've seen quite a few diploma exams, and on many of them I've seen a very similar picture like this one, and students are asked to identify, for example, what is the name of process Y or the process X, or how many chromosomes are in structure 1 and 2, and it goes on. And it's very important because this is the alteration of generation that you should be familiar about. And one last bio question. Again, we have a large context box here. I encourage students to read the question first before reading the context box. So the question says, plant species that consistently remain, and the key word here is consistently remain, in a grassland where grazing is prevented is known as, and we have several options here. The word consistently tells you that this is the most common or most dominant plant for a long time. Therefore, it fits the definition of a climax species. So that is our first choice of answer, but let's confirm our answer by reading the context box. It says, to study effects of grazing on biodiversity in a grassland community, scientists prevent sheep and rabbits from accessing a particular area of the grassland. They discovered that biodiversity decreased in areas where grazing did not occur because grazing prevents the most successful plant species from taking over an area. Aha! That matches our definition of a climax species. Therefore, our initial assumptions was right, and the correct answer is B. Let's move on to a Chemistry 30 question. All of these questions are taken from the November 2012 edition of the diploma exam. So question 5 looks at a calorimetry question, a thermochemistry question, where a student mixes hydrochloric acid with sodium hydroxide and monitors the temperature of the calorimeter over time. We see from the graph that the temperature increases over time, which then tells us this is an exothermic reaction. The system, the chemicals, is losing energy to the surroundings, the water. So the water is getting hotter because the chemicals is losing energy. So it's an exothermic reaction. And then question 5 asks us, which of the following potential energy diagram represents the reaction in the experiment? So we need to look for an exothermic reaction. And of the 4 options, A and D are endothermic, whereas B and C are exothermic. And lastly, unfortunately, I've cut off the delta H values here at the end, but we can see that here delta H is negative, which is the correct sign in an exothermic reaction. Therefore, the correct answer is C. So for this type of reaction, this type of question, it's important to interpret the question and then determine this is an exothermic or endothermic reaction, and then match it to the correct energy diagram. On question 11, we are given 5 different equations, and there's a lot of context box involved as well. Similar to bio questions, I encourage my students to look at the question to see exactly what's being asked. And the question is, the oxidation-reduction reactions in these equations given above are, so we need to decide which of the 5 reactions given to us are actually redox equations. So let's look at them. And in this case, we're looking at copper. So it's important to look just at copper first. So in equation 1, we have copper solid becoming copper ion, and that is a redox reaction. So yes, that is one redox reaction. In equation 2, copper ion stays as copper ion, therefore that's not a redox reaction. Equation 3, copper ion also stays as copper 2 ion, it's not a redox reaction. Reaction 4, copper ion, copper 2 plus ion, stays as copper 2 plus ion, so it's not a redox reaction. And last equation, copper 2 plus ion becomes copper solid, which is neutral, therefore 5 is a redox reaction as well. So from our 4 choices, only B contains 1 and 4, or 1 and 5 equations, and that is our correct answer. On question 14, we're given a picture of a cell and some background information. Once again, I encourage students to look at the question first. It says, the equation that represents a reaction that occurs at the cathode is, and we're given 4 choices. If you remember, for any electrochemical cells, a cathode is the reduction reaction. Therefore, automatically, we know that options C and D cannot be it because these are oxidation reactions. So now we'll narrow down to choice A and B. In choice A, we have the reduction of potassium ions in the liquid form into potassium metal in liquid form. And reaction 2 is water being reduced to hydrogen gas and hydroxide ions. Well, if we look at our picture now, we see that all we have in our beaker, in our reaction container, is liquid potassium hydroxide, or known as molten potassium hydroxide. There is no water in this reaction. One would think that because water is the stronger oxidizing agent, it would be reduced first, but because there is no water in this reaction, answer A, or option A, is the correct reaction. On question 19, we're given a table with three different alcohols and their 3 different boiling points. The question reads, using only information contained in the data table, when the alcohols in the tables are compared, they have the same blank formula but blank properties. Well, we're looking at boiling points, and therefore boiling point we know is a physical property of a compound. Therefore, we can eliminate option A and option C. So now we have to look, will these compounds all have, well, the same molecular formula or the same structural formula? Well, we look at the alcohols. We have butan 1-ol, butan 2-ol, and 2-methyl-propan-2-ol. Well, because the OH group, the hydroxyl group, is located on different carbons, therefore we know they can't have the same structural formula. Therefore, we can eliminate option D. Therefore, the only remaining option that is correct and viable is answer B. So this question can be done by easily looking at what options can be eliminated at first, and then choosing the correct answer that's left over. And on question 34, we have a equilibrium question. It says toluene is an important solvent and is produced by this equation. The key part is a technician placed 3 moles of toluene into an empty 1-liter flask. The flask was then stoppered and allowed to reach equilibrium. At equilibrium, 1.2 moles of hydrogen was present in the flask. Luckily for us, this question is in a 1-liter flask. Therefore, this becomes automatically 3 moles per liter and 1.2 moles per liter. Remember, in an equilibrium ice table, we need to do all the numbers using concentrations, moles per liter, and not the total amount, or moles. So we set up our ice table, and the key here is that we have 3 moles of hydrogen that is produced. Therefore, we must keep that in mind. So let's look at our ice table. We have our toluene here, plus energy to give you the the products. Initially, we have 3 moles per liter of toluene and nothing of the products. At the equilibrium, we're told that we have 1.2 moles per liter of hydrogen. Therefore, we must have gained 1.2 moles of hydrogen during the change process, the C row. If we have that amount, then we also must have made some amount of the C7H8. However, it's important to remember that we have a 3-to-1 ratio here. Therefore, we're going to get 3 times less the amount of toluene, C7H8, than hydrogen. Therefore, we're going to produce 0.4 moles of C7H8. Therefore, that's our equilibrium value. And as well, we're going to only consume 0.4 moles of the initial reactant, which is C7H14. So at the end of the day, we will have 2.6 moles per liter of C7H14. Now, we can use these numbers, these equilibrium concentration values, into our equilibrium expression to determine the equilibrium constant. And one more time, we have to remember, when we set up our equilibrium expression, it's going to be 0.4 times 1.2, but cubed because the coefficient of hydrogen here is 3, all divided by 2.60. It's very important to remember that the coefficient of hydrogen is 3, which affects the change values as well as the equilibrium expression. The last question we're going to look at is question 34, and it reads, solid citric acid was added to a flask containing water and then stoppered. Which of the following observation would indicate equilibrium had been established? And remember, an equilibrium is not the cessation or the stoppage of all reactions, but it's the equal rate of the forward and reverse reaction. And option C here, it says the reaction have stopped. Well, that can't be because that's not the definition of equilibrium. And then B, the mass of solid acid is completely dissolved. That's not true because in a solubility equilibrium, there should always be some solid left because the forward reaction is happening at the same rate as the reverse reaction. Option D, the pressure of the system is constant. Well, there is no pressure involved here because we're looking at solid being dissolved in water. We're not talking about a gas. So therefore, option A is correct. The mass of solid citric acid remaining in flask is constant. Again, that is because the rate of the forward reaction, the dissolving reaction, is the same as the rate of the reverse reaction, the precipitation of citric acid from liquid, from solution, into solid state. And finally, I just want to leave you with some exam tips on the day of the exam. You should know exactly when and where the exam will be held. Arrive early, approximately 30 minutes. That allows you to return your textbooks, to go to the washroom, to organize your materials, and maybe just briefly look over your notes one last time. You should have an exam kit ready in a large Ziploc bag. In an exam kit, you should have your writing utensils, pens, pencils, erasers, and rulers are really important for Physics 30 because you'll often be asked to draw a line of best fit. You can have highlighters, often useful to highlight or underline material, and removable stickers are really useful for Chemistry 30 for you to note where the position is on the acid-base table, as well as redox half reaction tables for the chemical species you're dealing with in that particular questions. You should definitely bring calculators. 2 is great because 1 may break or run out of batteries, and make sure you know how to use them. You should not be using your calculator for the first time on the day of your tests. You should bring some snacks and water. Ideally, snacks are quiet snacks, so gummy bears or dry fruit is great. Carrots and celeries, not so much. Water bottle would be great. I know some schools do not allow water bottles with labels. They only allow clear water bottles, so check with your teacher on that. You should wear warm, comfortable clothes in layers. The room may be too hot, the room may be too cold, but if you have enough layers, you'll be fine. Again, some schools do not allow for the use of hoodies, so make sure you wear sweaters without hoods over them. And during the test, make sure you take mental and physical breaks. For the diploma test as of 2018, you now have 6 hours to write it. Therefore, you have a lot of time. Make sure you take a mental break. Maybe put your head down for maybe 5 minutes. Take a nap if you want. It's important to go go to the washroom, of course. But even if you don't need to go to the washroom to relieve yourself, the act of getting up and walking around to and from the washroom may just provide you with just enough oxygen to get to your head, just the blood moving to your head to help you solve the question. Well, that's all the tips I have for you. I wish you all the best on your standardized exams, and especially on the Alberta diploma exams.